Hi doctor, I'm LIM PEI NI. For the title I chosen is Circularity in the kraft pulp production from elephant grass Penicillium purpureum. So let's look to the pre-processing for the elephant grass. So the 10 plants of elephant grass was used as the whole plant sample, which including leaf and stem are separated into the leaf and stem fraction. We used to remove all the free sugar and extractive from the oil sample were cut into the small pieces around 5 mm or milled and selected with a 20 mesh sheet. Wash in 95% ethanol for 48 hours, and then we will wash it in distilled water for a further 48 hours. Then using a solid extractor system, so the sample will dry in an oven at 45 degrees Celsius for 24 hours, and then store in the plastic bottle at the room temperature. Then we go to the pre-treatment for the elephant grass. The pre-treatment that I chosen is sulfuric acid. So the elephant grass will penetrate or untreat with sulfuric acid at 5, 10 or 20% in 100 ml glass water by addition of 60 ml sulfuric acid solution to 3 grams of sample which had already dried. So the pre-treatments were performed in an autoclave at 121 degrees Celsius for 30 minutes. After pre-treatment, sample was submerged in a cold water bath. The slurry was vacuum filtered using filter paper into solid and liquid fraction. The resulting pre-treated solid fraction was washed with distilled water to neutralize the pH and dried at 45 degrees Celsius for 48 hours. Solid fraction were then weighed and stored in the plastic bottle at the room temperature for further use. So while the liquid fraction were filtered using 0.22 micro filter period to use in the chemical composition analysis. Besides that, the pulping process that we have chosen is conventional kraft pulp mills. So the primary goals for the pulping is wood delignification. This process should be carried out while also preserving the cellulose and hemicellulose to the possible extent and desirable amount. Such step can be accomplished by using an aqueous solution containing hydroxyl OH and hydrosulfide HS ion as active component. This solution, widely known as white liquator, is consumed during the cooking of the wood chipping in pressure vessel at approximately 160 to 170 degrees Celsius. The result is the production of the wood pulp containing dissolved organic and soluble inorganic material. Then we will go to the washing stage is then needed to remove the majority of this material. The washed pulp is sent to be screened and the separate black liquator with a dry solid contain about 13 to 16% is sent to the recovery line, which is shown in the figure. So the chemical recovery cycle is necessary to make the pulping process economically feasible. After being concentrated to between 65 to 85% at the evaporation plant, it can be effectively burned in the recovery boiler for the regeneration of pulping chemicals. In turn, the boiler generates high pressure steam and reduces some waste steam in an environmentally friendly way. The non-combustion fraction becomes a hot molten inorganic flow consisting mostly the sodium carbonate and sodium sulfide. This molten melt is dissolved and subsequently pumped to the recalcitrating plant for white liquator preparation. So we go to the conclusion in this study. The potential of elephant grass fraction for ethanol production after acid pretreatment was examined. The acid pretreatment lead to increased removal of solid and hemicellulose from elephant grass leaf fraction and whole plant compared with the stem fraction. The hemicellulose removal was directly proportional to the acid concentration used in the pretreatment. The enzymatic hydrolysis yield after acid pretreatment was higher for the leaf fraction, followed by the whole plant and the stem fraction. This effect is likely due to the complex stem organization, which is associated with higher lignin content, crystalline and structural density. Overall, the analysis presented are highlighted the needed to take into account the inherent recurrence of each plant fraction when evaluating pretreatment conditions to ensure a high enzymatic hydrolysis yield for biofuel production. Moreover, the fraction could be used separately for different processes. The stem mostly recurrent fraction may be more useful for energy generation by combustion, while the leaf, which require less thorough pretreatment, is likely to be more useful in 2G ethanol production. For this slide is the reference that I have used for this presentation. So this is all from me. Thank you.